In today's lesson, we're going to continue factoring trinomials with a slightly different form. Before we get into that, we'll have a slight recap of what we did last week. So last week, we took expressions, trinomials such as x squared plus 7x minus 18, and we factored them down. So what we did was we looked at the last term here, which is negative 18, and we asked ourselves, what are the factors of negative 18 whose sum would be positive 7x? So we can go through the factors. We could do negative 1 times 18. Well, if I add those two together, I won't get positive 7. So I can keep listing them out. Negative 2 times 9 is negative 18. If I add these together, I do get positive 7. So we broke this middle term down into negative 2x plus 9x, like that. And then we grouped two of them together like that. We created binomials, and we looked for common factors within each set of parentheses. So this guy here has an x in common. That would become x minus 2. This one, we have 9's in common, so that would become times 9, x minus 2, like that. Now we notice we have greatest common factors that are expressions. So we're going to divide those out, basically undo the distributive property. So when I factor out the x minus 2, I'm left with the x plus 9. And this was our answer. In the next problem, we have what's called a perfect square binomial. So binomial inside, and it's being squared. And we learned that these will end up taking the form ax squared minus 2ab plus b squared. So in this case, we're going to square this term. So that would be x squared. That's our ax squared. We're going to square that term. That's going to be plus 16. And then we're going to double these. The middle term is negative 2 times a times b. So we're going to end up with negative 8x here. And that would be our answer. So the problems we have today are very similar to what we did last week. The only difference now is that we have a coefficient in front of the x squared. So we're going to look at how to factor these. But the first thing we always want to ask ourselves is there a greatest common factor? Because if there is, we can take that out first. In this particular problem, there is a greatest common factor. All of these coefficients have a 5 in common. So we can divide that out, and that leaves us with 5 times the quantity, x squared plus 3x plus 2. And then with this part in the parentheses here, we can ask ourselves the same questions we did in the recap. What are the factors of positive 2 whose sum is positive 3x? Well, that would be 1 times 2. So we can break this down. There's my 1x. There's the 2x, so I broke the 3x down into 1x plus 2x. And then we can continue to factor that as we normally would. Now it's starting to look a little more complicated with the brackets, but that's only because I took out the 5 earlier. We're still focused on what's inside, right? So here we have an x plus 1 in common. So I'm going to factor that out, and that leaves me with the x plus 2 there, and this is the final answer. So it's really all the same work. The only thing differently was we took out the common factor of 5 at the very beginning, and we brought that along with us for the ride throughout the problem. Now we're going to focus our attention to problems where there is no greatest common factor. So here's how we handle these. We're going to take our a term. So let's just remind ourselves, we've got ax squared plus bx plus c. We're going to take our a term and multiply it by c. So in this case, we're going to do 4 times 3, which is 12. So I took this value and that value, okay, multiplied them together to get 12. And now I'm asking myself, what are factors of 12 that add up to positive 13? Right, so b is 12, and my factors of 12 that add up to 13 are 12 plus 1. So now that I've got that, I can break this problem down into 4x squared plus 12x plus my 1x plus 3. So really, it's the same thing we've been doing all along, except to figure out that middle part, we had to do 4 times 3, or a times c. And now we treat this like any other problem. I can group these, and I take out a common factor. So in 4x squared plus 12x, the common factor is 4x. That leaves me with x plus 3. In the 1x plus 3, the greatest common factor is 1, so I divide by 1. Now my greatest common factor is the x plus 3. So we divide that out, and I'm left with 4x plus 1. And that is my answer. Let's look at another problem like this. So we're looking for our a times c, which in this case is 2 times negative 7. So that's going to be negative 14. Now I need factors of negative 14 that add up to negative 5. So my factors of negative 14 that add up to negative 5 are negative 7 times 2. And we know that negative 7 plus 2 is negative 5. So we're going to break this down into negative 7x plus 2x now I can see here I've got 2's and 7's throughout the problem, so I can keep it like this. If I wanted, I could also rearrange it. Like this. And then group like that. So I've got a statement where the 2's are in common, and then a binomial where the 7's are in common. So we'll divide out our greatest common factor, which in 2x squared plus 2x is 2x. So that leaves me with x plus 1. On the left side here, negative 7x minus 7, they have a negative 7 in common. So divide that out, and that leaves me with x plus 1. We can see that these are our greatest factors now. So we divide those out, and we get 2x minus 7. And that would be our answer. All right, in our next set of problems, we're going to be factoring special products. So here we have x squared minus 9. And the first thing I notice is that my x squared and my 9, they are perfect squares. We know that the square root of x squared is x. We know that square root of 9 is 3. So what we have here is a difference of squares. Difference because we're subtracting them. We're subtracting the perfect squares. And these will take the form a plus b times the quantity a minus b. So we already figured out what the square root of a squared is and the square root of b squared is. It's x and 3. So this would be x plus 3 times x minus 3. And if I wasn't sure about this, I could always test it out and check my answer. X squared, 3x, negative 3x, and negative 9. And I could see right here, look, these terms would cancel each other out, and that would leave me with x squared minus 9. So I know I've done the work correctly. In the problem 4x squared minus 25, we have a difference of squares again. We know that the square root of 4x squared is 2x, and the square root of 25 is 5. So already we have our answer in a difference of squares. It would be 2x minus 5 times 2x plus 5. And that would be the answer for that one. In this problem, x squared plus 6x plus 9, I again notice that the first and the last terms are perfect squares. So what we have here is a perfect square trinomial. So we're going to factor that now. We know that perfect square trinomials that we did last week, so we looked at these last week, will equal, when factored, the square of a binomial. In this case, the quantity of a plus b squared. Well, we know that a squared, the square root of a squared is x. We know the square root of b squared in this case is 3. So this is going to be x plus 3 squared. And we can test this out. If you're ever unsure, test it out. X squared, 3x, 3x, 9, x squared plus 6x plus 9. This next problem is very similar to the one we just did, except now we are subtracting and adding. And we know from last week that we can get this kind of trinomial, perfect square trinomial, when we have a minus b, the quantity of a minus b squared. So as we learned up above in the previous problem, the square root of a is x, the square root of b is 3, and because we're subtracting in the middle, we would have to subtract here. So this would be the quantity of x minus 3 squared, and that is the answer. So the problems we're working on today are basically, we're just taking the work we did last week and we're working backwards now. If you have any questions or need any help, send me an email. I'll get back to you as soon as I can. And if you're not happy with your score on any assignment, let me know and I can reassign just the incorrect problems to you so you can improve your grade. Good luck, guys.